Hi everyone, just wanted to take a minute to talk a little bit about area. So this is going to be a very broad overview. You've seen a lot of these formulas before, you've probably used them a number of times before. This is really just to kind of reiterate the different formulas that will be available to you to use on the MCAS in terms of the reference sheet. So let's talk about what we are doing today. So we're going to calculate the areas of different shapes given area formulas, and then we are going to use those to find the area of shapes that are kind of irregular. They are known as composite figures, which are made up of other shapes. All right, so this is what you're given in terms of your MCAS formula sheet. So you're given a square, rectangle, parallelogram, triangle, trapezoid, and circle. So our goal really is to just be able to plug in the appropriate information into these formulas and know how to use them. So we're going to start off, we're going to go in order. Let's start off with the square. Area is equal to the side length squared, right? We know all sides of the square are the same. So that means if we have a square of side length 8, we do 8 squared. So the area is 64. And remember, area being like how much space it takes up, that makes sense. So it takes up 64 feet squared. Don't forget your unit, that is very important. Okay, so we have 64 feet squared. All right, next, the rectangle. The rectangle has the area of base times height. That one will be relatively straightforward. You've probably done this many times. That area is going to be equal to 8 times 3. The area is equal to 24. Don't forget your unit of centimeters squared. All right, now, as you know, a rectangle is a type of parallelogram, so it makes sense that the area of a parallelogram is going to be the same thing of base times height. Realistically speaking, a square, which is also a rectangle, also is base times height. It's just that the two sides are the same. So with a parallelogram, you are again going to do base times height. Now, the thing that you do need to be careful of is that the height of a parallelogram is the one that makes the perpendicular line here, the right angle. So it's the 5, not the 6. Be careful. Okay, so similarly, you could have this one over here. It's the 5. It's kind of the thing that makes it look like a rectangle. So my area is equal to 5 times 10, equal to 50, and then I have inches squared. All right, now we have a triangle, which is 1/2 base times height. That makes sense, right? If you looked at a rectangle and you cut it in half, you get 2 triangles. So of course the area of a triangle is going to be 1/2 base times height. So the hardest part about this is identifying what the height is. So the height can be a couple of different things. In general, it'll just be the altitude on the inside, right? The altitude, the line from the vertical, from a vertex to the opposite side that is perpendicular. But what do we know about altitudes? Well, they can be outside of the triangle. So if you had a triangle kind of like this, this would be the height if you drew out here. Similarly, if you have a right triangle, you already know that this is the height, or this number over here would be the height. All right, so they can be sides of the triangle or they could be inside. In this case, it is on the inside. So you have 1/2 base 8.7 times the height. Don't forget your height will be perpendicular to your base. Don't forget that. So if you're using the 8.7, you have to have the 5.4. If you had a line over here like that, using that altitude, it would be this base and this height. All right. So that is equal to, well, let's multiply this out. So 1/2 is the same as 0.5 times 8.7 times 5.4. That ultimately is equal to 23.49. My unit is centimeters, for the centimeters squared. Now you do need to be careful. It is very easy to forget about the 1/2. Do your best not to forget about the 1/2 because that is a very easy thing and common thing for people to trip up on. All right, next one, trapezoid. We have the area of a trapezoid is 1/2 times the height times base 1 plus base 2, okay? So let me show you what that means. So see here, we have the height, right? The height is going to follow the same rules as it did in the parallelogram and the triangle. It's got to be perpendicular. But now we need specifically base 1 plus base 2, and we are also still dividing it by 2. To 1/2 height times base 1 plus base 2. There's a couple different things you could do to figure out where that comes from. Notably, right, if you kind of draw it out, right, you have some triangles that you can add together and have a rectangle. And you can kind of use that to compose it all together and get the 1/2 base times height. But ultimately, you're going to use the formula of A equals 1/2 base times height. Oops. Base 1 plus base 2 times height. Sorry. B1 plus B2. Oh, that's probably B. All right, so my base 1 is 6 or 8, doesn't matter which one it is. My height is 4. Again, you have to use the perpendicular line. So base 1, or we can call it 6, or we can call it 8, doesn't make a difference. So I have 1/2 times 4. 1/2 times 4 is 2. 6 plus 8 is 14. So that is equal to 28. We are not given a unit, so what you can do is you can just write units squared. Now that is probably one of the trickier ones, just because you have to remember to include all the different parts, including both bases and the height, and put them in the correct order. All right. Don't forget about the 1/2 as well. All right, last one, I believe. We have the circle, which is area is equal to pi r squared. So if we take a quick look at something like this, we are given the circle, we are given the diameter. We do not want the diameter, we want the radius, which is half the diameter. So the diameter is 50, the radius is 25. So your area is going to be equal to pi, my r is 25, squared. So 25 squared is 625 times pi. All right. Oops, sorry. Now, I personally prefer to leave it in this form. You can just then leave it as centimeters squared. If it asks you to round, it likely wants you to use pi as 3.14, or alternatively, you can use the pi button on your calculator. But 625 times pi ultimately will give you about 1,963 if you are to do it out. But you can leave it as 625 pi, which is approximately 1963 centimeters squared. All right, so that is ultimately the different formulas you have. But what we're really going to care about is if we are given figures that are not necessarily any of the ones that you are dealing with. Most notably, what you're going to be dealing with is something called a composite figure. So it's going to be made up of other figures you know. So there's a couple things you could break this into, right? So, here you have a trapezoid, you have half of a circle. Alternatively, you can kind of break it up into, a rectangle and some triangles and a circle. But ultimately, you know the different area formulas for parts of these. So what you're going to do is kind of add them together. All right. So let's take this one as an example. So we have an area below made up of an isosceles trapezoid, which means that these are the same, and one semicircle. All right, so a semicircle is a half of a circle. So the area of a semicircle is if I took the circle, which is pi r squared, and I divided it by 2. Okay, so we need to be careful. What are we looking for? We're looking for the area of the whole thing. We have a trapezoid, right? So if I kind of looked at it here, I could find the area of that trapezoid, area of the trap. Okay, that's 1/2 the height, which is 4, times base 1 plus base 2, so 5 plus 2. Okay, what does that equal to? Well, 1/2 times 4 is 2. 5 plus 2 is 7. So it's 14. Now I need the area of the semicircle. Now it doesn't want the diameter. That's the diameter. It wants the radius. So that's 1. So it's 1 squared times pi divided by 2. 1 squared is 1, so it's just pi over 2. All right, so wants the whole thing. I have to add it together. So the area is equal to 14 plus pi over 2. It wants me to round that to the tens place. So 14 plus pi divided by 2 is 15, sorry. It is 15.6 units squared. All right, so again, all I did was I took this apart, I looked at it as a trapezoid and as a semicircle, added them together, and that's how I got my answer. Let's do another one. So we are now given a parallelogram and 2 semicircles. By the way, if you have 2 semicircles with the same diameter, it adds up to a circle. So remember, this is a parallelogram, so this is 16, this is 16. So these semicircles are essentially both half of a total circle. So I don't need to look at them as halves. I can just look at it as a whole. We are given a diameter of 16, so it has a radius of 8. Okay, so let's find the area of the parallelogram. That is 11 times 32. What is 11 times 32? That is 352. The area of the circle, remember, because there are 2 semicircles and they are the same, that just makes one whole circle, right? 2 halves of a circle make one circle. So you have 8 squared times pi, which is 64 pi. And it wants me to add them together. So the area of the total is equal to 352 minus 64 pi. Oops, sorry, plus 64 pi. But it wants me to figure out what that is. So in total, it is 553.1 units squared. Again, simple enough. All you're doing is you're looking at shapes you know how to calculate area of and adding them together. Now there is one more scenario you could encounter. This one is slightly different from the other ones, but it has the same process. Here we have a rectangle with a semicircle removed. So if it's been removed, instead of adding, you will subtract the semicircle. Now this is a rectangle, so if I were to draw this, this would be 6. So it has a radius of 3. So the area of it, if this was a whole rectangle, right? If I looked at the shape as a whole, the area of the rectangle would be 6 times 8, which is just going to be 48. But I don't want 6 times 8. That would be the whole thing. But we cut out this semicircle. So the area of the semicircle is going to be 3, because that's the radius, squared times pi divided by 2. Well, what's 3 squared? That's 9. 9 pi over 2. So my area in total is going to be 48. Instead of being 48, which is the whole rectangle, I'm going to subtract out 9 pi over 2. And it wants me to round, so 48 minus 9 pi divided by 2, which gives me a total area of 33.9 units squared. All right, there you have it. So that is everything that we are going to be dealing with in terms of area. It's going to be just kind of more of a broad overview, so please let me know if you have any questions. Have a great day.